Imagine floating in the vast, boundless expanse of space, surrounded by billions of stars, swirling galaxies, and the unknown. The universe, it's not just where we live, it's everything. A realm of mystery, stretching beyond what we can see or even understand. Today, we're going to take a journey across time and space, exploring some of the biggest questions about the universe, from its beginnings to its potential endings, from mind-bending concepts to familiar sights seen in a new light. The universe, a journey across space and time. Part 1, the birth of the universe. Let's go back to the beginning. Around 13.8 billion years ago, the universe as we know it began in an event known as the Big Bang. But what exactly was the Big Bang? It wasn't an explosion in space, it was the rapid expansion of space itself, from a point smaller than an atom to what would become an immense, dynamic universe. In that first fraction of a second, the universe grew exponentially, expanding faster than the speed of light. During this phase, called cosmic inflation, space itself was stretching, carrying with it the building blocks of everything: matter, energy, and the fundamental forces that govern the universe. In the span of seconds, particles formed, collided, and combined, eventually creating the first hydrogen and helium atoms. These elements would go on to fuel stars, the engines of the universe. Part 2, the formation of stars and galaxies. Now, let's fast forward a few 100 million years. The universe has cooled enough for gravity to take center stage, pulling atoms together, forming clouds of gas, and eventually igniting the first stars. These massive stars fused hydrogen and helium into heavier elements, lighting up the early universe and creating the conditions for galaxies to form. Galaxies are the universe's megacities, vast structures of billions or even trillions of stars, held together by gravity. Within these galaxies, stars live out their life cycles, some ending in spectacular explosions called supernovas, which scatter elements across space. And then, there are black holes, regions where gravity is so intense that not even light can escape. Part 3, expanding horizons, the scale of the universe. When we think about the universe's size, we have to imagine something that seems almost incomprehensible. Earth orbits a single star in a galaxy of around 100 billion stars, which is just one of over 100 billion galaxies in the observable universe. These galaxies are grouped into clusters, which are further grouped into superclusters, spanning hundreds of millions of light years across. At the largest scale, galaxies are not evenly distributed but form a structure known as the cosmic web, with dense regions linked by strands of galaxies and vast voids in between. This interconnected network gives us clues about the universe's underlying structure and the mysterious dark matter that seems to hold it all together. Part 4, dark matter and dark energy. Dark matter and dark energy are two of the biggest mysteries in modern cosmology. Together, they make up about 95% of the universe, yet we can't see or directly measure them. Dark matter acts like an invisible scaffolding, holding galaxies together, while dark energy drives the universe's accelerated expansion. Dark energy is a strange force, pushing galaxies apart, causing the universe to expand faster as time goes on. Scientists have observed this accelerated expansion, but they still don't know what dark energy actually is. It's like a cosmic game changer that could determine the fate of everything we know. Part 5, the search for other worlds and life. As we look up into the night sky, it's natural to wonder, are we alone? Over the last few decades, astronomers have discovered thousands of exoplanets, planets outside our solar system, many of which orbit their stars in a habitable zone where liquid water could exist. With powerful telescopes like the James Webb Space Telescope and new exploration methods, scientists are identifying planets with atmospheres and conditions that might support life. Finding even the faintest sign of life beyond Earth would transform our understanding of our place in the universe. Part 6, the fate of the universe. One of the most intriguing questions we face is, how will the universe end? Cosmologists have proposed several theories. The most accepted model, the Big Freeze, suggests that as the universe keeps expanding, galaxies will drift apart, stars will burn out, and everything will eventually cool to near absolute zero. Another theory is the Big Crunch, where gravity could slow and eventually reverse expansion, causing everything to collapse back into a single point. There's also the Big Rip, where dark energy grows strong enough to tear galaxies, stars, and eventually atoms apart. Each of these fates is a different outcome, yet they're all based on the cosmic laws that govern everything around us. Part 7, humanity's journey in the universe. Our curiosity about the universe drives us to explore and understand. Space missions, telescopes, and probes have taken us to the edge of our solar system and given us glimpses of distant worlds. Yet, as vast as our achievements seem, they are just the beginning. The universe is not just a destination, it's a journey that will continue for as long as we look up and wonder. One day, we may unlock the secrets of dark matter, explore other galaxies, or even find life on other planets. The universe may be vast and, in some ways, unknowable, but with every discovery, we grow closer to understanding our place within it. Thanks for joining us on this journey through the universe. From its explosive beginnings to its awe-inspiring mysteries, the universe reminds us of how much more there is to explore. Until next time, keep looking up, keep asking questions, and remember, in the grand scheme of things, we're all stardust. Subscribe for more videos on science, space, and exploration.